Alright, I'm going to start with the same two equations that I did for known cross sections, and I'm going to graph them. So I know x squared and then 2x plus 3, and these, it's a sketch in terms of what it'll look like. I want to know what top subtract bottom is. Now, if I make them equal to each other, just like last time, that's finding the limits of my integration. And so all of that's important. Our base in this situation, we're revolving in this one, so it's going to be circles. So our base is actually the radius, not the diameter. So when I go top subtract bottom, I need to realize that it's the radius. But first, let's talk about revolving around something. Let's say a revolve around the x-axis. So this is the x-axis. Is there a space here between the area and the x-axis? There is. And so that creates what's called a washer. It creates two circles. So for that, it's going to be pi. The bounds are -1 to 3. And I'm going to have 2, and I'm going to subtract them. So I'm going to have a big circle and a small one, and then I'm going to subtract. So the big radius from where the x-axis all the way to the top of the area, that's the line, 2x plus 3, take away 0, which I don't need, and then the small radius from the line to the bottom of the area. So that's the curve, take away 0. That's x squared, take away 0, or just x squared. That's revolving around the x-axis. Let's say I revolve around a line. So let's say I pick a line like y equals -2. I would go here to -2. Again, you can press pause. And go, okay, there's a space. There are two circles. So I set it up. So it's pi, -1 to 3. I know that there is a space there. So it's a washer. I need a big radius and a small radius. So for this one, from this line to the top, again would be the line, but this time take away -2. So it'd be 2x plus 3, subtract -2. That's the big radius. And then if I come back here, again from -2 to the bottom of that curve, it's the curve, the bottom part. So it's the curve, subtract -2, and it's done. Now, if I just take a function that's not a washer, right? So let's say -x squared plus 4 with the x-axis. We're going to revolve. So in this situation, -x squared plus 4, I would start at 4, and then with the x-axis, it's completely solid. There's no space there. So the bounds would be -x squared plus 4 equals 0. So I'd have to add x squared and square root, and it's positive and -2. So I already know it goes from -2 to 2. We're revolving, so it's pi, and there's only one circle. That's it, because there's no space. And then top subtract bottom is -x squared plus 4, take away 0, or just -x squared plus 4, and you did it. All right, there's your quick review on finding volume by revolutions. Till next time.